they agree with your conclusions. And when I'm not speaking to scientists, I speak to environmentalists. And that's also a pretty easy audience because you're essentially trying to impress people with the urgency of a problem or a set of problems that they already believe in. But this is a little different. And I'm going to begin by telling you kind of an overview of what I'm going to be saying today. And then I've got, for the first time, speaking to a general audience, I'm going to not throw out a whole lot of facts, but I'm going to throw out a whole lot of images. And these images are going to be photographic, but they're also going to be video images. And so we'll see how this works. We're about to see a multimedia extravaganza. So, as I said earlier, the way I got involved in all of this, and the reason that I am still teaching at Western Wyoming Community College is the proximity to the glaciers in the Wind River Range of Wyoming. And I've been studying these glaciers for about 30 years now, about 3 decades. It'll be coming up this summer, it'll be 3 decades we've been looking at the glaciers in the Wind River Range. But the message for you folks, for consumers of water, and for people who live in the Colorado River Basin, is not going to be so much about the disappearing glaciers of the Wind River Range, as it is going to be a very simple plea to you to involve yourselves in solving a problem that I see on the horizon that is intimately linked with the problems that Hunter Lovins described this morning. Excellent speech. And I'm afraid it's not going to be real news to you, because what I'm going to be saying is demand for water is increasing. It is throughout the basin. We're exporting a lot of water throughout out of the Colorado River Basin. And while the demand is increasing, the supply is becoming more erratic, and we are losing frozen reservoirs in our headwaters. Okay? So let me begin. I've been suffering with a bit of a cold, and so I've got cotton mouth right now, and what I'd like to do is just sort of describe to you from the beginning what I understand to be sustainability. Okay, so what do I understand to be sustainable use of water resources? Well, it's pretty simple. It's not taking more from nature than nature can provide. But for the students in the audience, when I work with my students, we have a definition that we have pasted up on the wall in our classroom. And they helped us put together this definition. And so sustainability for future generations becomes part of the whole thing here. Because as we are tied year to year to the water that falls upon our land, we have to recognize that we can't take more from nature than it will provide. So sustainability for my students becomes meeting one generation's needs while not compromising the ability of future generations to meet their needs. Okay? So that's what I'm doing. That's my definition of sustainability. Sustainability, this is the single most important point that I want to make. Sustainability of water resources in the Colorado River Basin is going to be continually, annually redefined for our foreseeable shared future in this basin. That's it. It's a very, very simple message. Okay? How to come up with this? Let me first define the basin, and we'll talk about this. So what you see here, this is a U.S. Bureau of Reclamation map. And the U.S. Bureau of Reclamation has just in December of this year come out with a brand new study, a planning study on how much demand there is and what supply there is throughout the basin. So you can see the hydrologic divide. That's the catchment area. If you've taken a hydrology course here of the Colorado River Basin. Most importantly here, what I want to point out to you are these areas: Denver, Fort Collins, the Front Range of Colorado, down to Pueblo along the Arkansas River, the Central Valley, the Rio Grande Valley of New Mexico, and here we are with Salt Lake City and Ogden right here. All of these areas that are adjacent to the basin are areas that receive water out of the basin. So water falls in this basin and it's pumped over the divides into 60%, for example, of the water that is consumed in the Colorado Front Range here. Even though it's out of the basin, 60% of the supply is from our basin. Okay? I want to point this one out here because this is going to be real critical later on. 19 million people in the Southern California Water Conservancy District, okay? 19 million people. Roughly, when the Colorado River Compact was drawn up, we said the upper basin states, Utah, Colorado, New Mexico, and Wyoming, are going to get 7.5 million acre-feet of water a year, and the lower basin states are going to get 7.5 million acre-feet of water per year. Right now, 4 million acre-feet of water is the demand here in the Los Angeles basin alone. Okay? Message here, it's pretty clear. A lot of the water that falls in the Colorado River Basin is pumped out already. Okay? And the basin is over-allocated. We already have a lot of all of the water that's in the basin, and our supplies are declining. Supplies are declining while the population is growing. So here we are. I think we're right now 37 million people in the basin. In 2015, we're expected to be at 40 million. A huge portion of that growth is going to be in Utah alone. Luckily, you're in one of the upper basin states. Well, but here are the projections. Slow growth has us about 50 million people in 2060. High growth projections show us almost doubling the population in just the next 50 years or so. Right? So, how does supply and demand work itself out on the graph? Well, here is here's where we were when the Colorado River Compact was signed. Everybody thought, we've got plenty of water, 20 million acre-feet of water or so per year, and as soon as the compact was signed, water volumes started decreasing. Okay? Now this is the sum total of all of the water that falls in the basin and runs through the Colorado River system. We had a little respite here, and this was about 1982 or so, we actually climbed up to historic highs, but again, it fell off, all right? And so water use, on the other hand, you can see that this is a continual, almost linear curve, you know, showing the increase in demand for water. So this study that I'm referencing, I've got a copy of it right here, tells us that in general, what's going to be happening due to climate change and to decreasing and more erratic runoff is that we are going to be running about 9% less water in the Colorado River system than we have historically seen as our average. While the demand, as you can see in this red blur here, will continue to increase. And so what I'm going to be talking about is how we address the difference here between the demand and the supply. a supply that is becoming increasingly smaller, while it is becoming increasingly erratic. And you cannot divorce those two characteristics from one another. Here's an example. This is water running into the Flaming Gorge Reservoir. And what I want you to see in this graph is simply the difference between the highs and the lows. Here we are at a figure that looks to be about 1/10 as large as the highest value of runoff that is seen into Flaming Gorge. Flaming Gorge is, of course, the headwaters of the Green River, the headwaters of the Colorado River system. Critically important here. It's also right in Utah. It's right in up in the northwest corner northeast corner near Manila, Utah. So water supply is unpredictable. It's going to become increasingly more erratic, while it is declining in the next 50 years by at least 9%. Okay, and what do we get when we have hotter, drier climates? We lose water through evaporation in the big reservoirs that we have created to mitigate this problem. Okay? And I'll be showing some pictures about that over a little bit later on. But to give you an example of what that means, in the southwest corner of Wyoming, we get from 7 for a desert, we get from 7 to 10 inches of precipitation each year. Okay? We evaporate. We have an evaporation potential of 3 times that much, almost 17 inches. Okay? And as you get a hotter, drier climate, this evaporation rate is going to increase throughout the basin. And we can see this. This is the characteristic bathtub ring at Lake Powell. Okay? And this is the conclusion of this study, which I think is very, very credible, and I think is borne out by the data. And I can show you some of that during the question and answer period if you want. So 9%. I can live on 9% less money. I know that. Okay? So 9% might not seem like such a big deal to you. But a 10% drop in flow is going to mimic the conditions of the worst drought that we've ever seen in the last century. That's what a 10% flow really means in the Colorado River. 10% flow decrease really means in the Colorado River system. Oh, and as you can see in this graph here, this is the minimum pool at Lake Powell, and you can see as evaporation, you can just watch the water drop, where it was 85% full in September of 1999, September of 2004. Evaporation and release actually dropped that value to about 36%. So we have the reservoir capacity to mitigate this, but the problem is a change in climate means the more reservoirs that are out there, the more the evaporation potential, and less water. Okay? Another conclusion of the study is droughts in the Colorado River Basin that are 5 years or longer are going to occur 50% of the time. Okay? That's a huge deal. Look at the evidence. This is July the 24th of 2012. This is the Colorado River Basin. Okay? And you can see that it is either in severe, extreme, or exceptional drought throughout the entire basin. This was last year. Okay? Wyoming had the driest and the hottest year ever last year. Throughout the United States, temperature records and drought was the rule and not the exception. Hunter talked a little bit about this, the intensity of severe storms and the frequency, how often those severe storms occur is expected to increase. And this is not just in the coastal areas. And this makes great sense to scientists, because scientists understand that, you put more temperature, you heat up a system, and things begin to change. You put more energy into the system, and especially in a system as complicated as the fluids, the liquids, and the gases in our atmosphere, as this all turns about, we're going to get more erratic storms, and they're going to occur more often, and the storms are going to be more frequent. Is this news? In 1980, just about the time we started studying the glaciers, Jim Hansen came out and said two things. The dry areas on this planet are going to get drier, the wet areas are going to get wetter, and the areas that are susceptible to storms are going to see bigger storms of greater intensity, and we'll see those storms more often. So it's not news. But does what has happened in the last 5 or 6 years spell this out? You bet it does. You think about Hurricane Katrina. Half the population of New Orleans left. Okay? And a quarter of that population didn't ever come back. Huge numbers of environmental refugees are now settled in other parts of the country, thinking that, well, maybe it was the coastal regions that was where we were going to get the biggest storms, and we're going to avoid them. We're all moving inland. This is a reference from Richard Seeger out of Science magazine in 2007. What he said about the Colorado River Basin in the western United States: the best models project an imminent transition to a drier climate in the Colorado River Basin. In the upper left-hand corner, what you see here is a dust storm last summer over Phoenix. A dust cloud reminiscent of the Dust Bowl days. And what you see in the lower right-hand corner is downfall due to pine bark beetle kill in the Rocky Mountains. My wife and I attended a conference in Jackson, and this conference was put on by the Forest Service in response to a huge public outcry over the number of beetle-killed trees that people were seeing. And they wanted the Forest Service to do something. And the Forest Service came back and said, you know what? Not only can't we do anything about this, but we think it's going to get worse. So here are foresters. Right here in Ogden, you have the Intermountain Forest Research Station of the Forest Service. Why can't you do anything about it? Well, the answer came back to us that the reason they couldn't do anything about it is because it was caused by climate change. Well, what's the interaction between pine bark beetles and climate change? The interaction is simple. In the days before climate change hit with such intensity in the western United States, these pine bark beetles lived inside the bark, and they could be killed in a couple of ways. One way is that the trees could freeze solid, but it took temperatures of minus 50 degrees Fahrenheit to do that. The other way is you could get rapid freezes after they had emerged out of the tree. Okay? And so the Forest Service entomologists that were explaining this to us said, not only do we not see those low temperatures or those storms that occasionally froze the beetles when they were emerged out of the tree and breeding, we don't see those storms anymore. But worse, climate change had warmed the climate to the point where the beetles, which normally bred once per year, were getting 2 breeding cycles per year. Now, any of you have taken a class in population or a class in environmental scientists know that the exponential growth equation has some coefficients, okay, in the exponent of that equation. And if you get 2 breeding cycles per year when you had only got 1 before, what that does is it squares the exponent in the exponential growth equation. And that's why from Yukon to where the forests run out into Mexico, we have seen such massive beetle kills. Okay? What does that have to do with water? kill all the trees. You have a snowpack that is no longer shaded, and you're going to get more erratic runoff because the snow will melt faster, there's nothing to keep it there on site, and it's going to come earlier in the year. So you're going to get a huge dose of snow runoff earlier in the year, and the net result of that combines with the erratic flow pattern that I've described before. Okay? How am I doing? Questions? Okay. So, we have to ask the questions. If we have such erratic flow patterns, one way of evening all of this out is to build some more reservoirs along the Colorado. Is that the answer? Well, the study that I'm referencing here actually put numbers to this. And it is less expensive to desalinate seawater, which probably 40–50 cents a gallon, okay, than it is to create new reservoirs in the main stem of the Colorado. Okay? So that isn't obviously going to be the answer. So what is the answer? Well, I think one of the answers to an incredibly complicated problem, and I'm glad my talk is going to be followed up by some people from sociology, because these are questions that must be answered by a community of people, not by scientists. It can't be answered by scientists. But one thing we can do is preserve our headwaters. The glaciers in the Wind River Range of Wyoming are the most extensive glaciers in the contiguous United States outside of Alaska. Okay? Many people don't realize this. We have over 100 glaciers there. About 60 of those glaciers are named, and these are the headwaters, not just of the Colorado, but also the Snake Columbia system and the Missouri-Mississippi system. So I call them no-cost, zero-maintenance, fully automatic, high-altitude, vandal and terrorist-resistant reservoirs. They're free, and they're there. And they are automatically programmed to melt at exactly the time to provide runoff when we need it, okay? Are there problems? Yes. Worldwide, we are losing these high-altitude frozen reservoirs. This is one of our study glaciers in Switzerland, Morteratsch Glacier, and as you can see here, when you look at this peak right here, this is the same peak, the same photograph. It's a little bit different angle. We're down in here. This is a 1923 photograph, okay, of Morteratsch Glacier. There are 3 little peaks here. These are the same 3 peaks here, okay? This contributing glacier has completely disappeared. And what you see is the emergence of bedrock, okay? As soon as bedrock starts emerging in a mountain glacier like this, it absorbs heat and contributes to the meltwater. This sign here says this is where the tongue of the glacier was in 2010. We took this photograph in April of 2011. One melt season, took a GPS reading right here at the base, walked over to the glacier, took another GPS reading, 75 meters in 1 year. And it's thinning in an equally catastrophic fashion, okay? So this kind of tells you the same story. But if you look up here, along this moraine, this is where the glacier was when that photograph was taken in 1923. Is it limited to Switzerland? No, this is also a 1923, I might have messed up my dates now. This is a 1923 American Sportsman magazine. This is called the Elephant's Head. If those of you who are alpinists and know anything about the Wind River Range of Wyoming, this is the flank of Jackson Peak, and this is Indian Pass, the lowest point on the horizon. If you were to be standing on the glacial moraine above Fremont Lake, Fremont Peak would be the highest point, and Indian Pass is going to be the lowest point. This is 1923. This is 1988.
Bull Lake Glacier has almost completely disappeared. This ice fragment can no longer be considered to be a glacier because it's not sliding downhill. Lower Fremont Glacier has completely disappeared. And Knife Point Glacier, where we saw just all snow and ice, has this giant rock buttress here and is retreating at about half the rate that we see recession in glaciers in Switzerland. Is it just the mountain glaciers? Continental glaciers are disappearing as well. This is the well-known collapse of the Larsen B ice shelf, okay, which occurred in a matter of months. In 2002, we have Piedmont glaciers that are melting so fast that they virtually have no runoff stream, okay? And we have tidewater glaciers that are also melting. Let me tell you why ice is so important. If you look at the globe from afar, one of the things you'll see is the huge amount of white reflective cloud cover and snow and ice cover, okay? The reflectance is called the albedo, and ice essentially acts as a giant heat buffer, okay? Any of you who've taken general chemistry, check my watch to make sure I don't get too professorial on you and start explaining things that take up all my important time. But you remember that to warm 1 gram of ice from -1 degree centigrade, 1 degree below freezing, to 0 degrees centigrade, the melting point of ice, requires a little less than 1 calorie. But to melt that ice and produce 0 degree water from 0 degree ice requires 80 calories of energy, okay? That means it can absorb a tremendous amount of heat and give that heat back to the environment and basically act as a temperature buffer. But if you lose ice mass and you lose snow cover and you lose cloud cover, what you're going to get is a darker system. We know this can't work. How do we know it? Well, in Ogden, think about this. It's August the 5th, 2013, and you walk back to your car in the parking lot. Hopefully you've taken public transportation, but if you walk back to your car in the parking lot and you've got a choice, which car are you going to jump in? A white car with a white interior that is a convertible, or a black coupe with a black interior, okay? As we lose the reflectance from ice and cloud cover and snow cover, what we're going to be doing is accelerating the rate of climate change, okay? That increases the evaporation rates, that decreases the supply, and losing our ice buffer in the headwaters basically means the headwaters are going to become as unstable as deforested areas in the uplands. Does that make sense? Okay. So, where's all the ice gone? This is just shows cumulative decrease in global glacier ice. This graph simply reinforces what I'm saying. We're losing mountain glaciers, we're losing continental glaciers, we're losing the ice layer in the Arctic. And I want to do something that I've never done before, and this is show a video. Okay, I'm going to show a YouTube video on how catastrophic this might be. This is actually, if I can, This video is a little bit out of scale, but what you want to imagine is this is the size of Manhattan. So map that.
I'm on the phone with Jim on one of our regular check-ins. Jim, just nothing's happening.
It's going well. We had a serious bout of wind, but other than that, things are fairly well set up. They just got
It's starting out, I think, starting.
Yeah. Let me call you back.
Okay, bye. Yeah, is that the lead section right there? Holy shit, look at that big bird rolling.
This is a tidewater glacier. A glacier that originates in the mountains and actually ends up in the ocean.
See, look at the whole thing.
Shooting up out of the ocean 600 feet and then falling. The only way that you can really try to put it into scale with human reference is if you imagine Manhattan. And all of a sudden, all of those buildings just start to rumble and quake, and peel off and just fall over, roll around. This whole massive city just breaking apart in front of your eyes. We're just observers, these two little dots on the side of the mountain. We watched and recorded the largest witness cabbing event ever caught on tape.
So how big was this cabbing event that we just looked at? We'll resort to some illustrations again to give you a sense of scale. It's as if the entire lower tip of Manhattan broke off, except that the thickness, the height of it, is equivalent to buildings that are 2.5 or 3 times higher than they are. Miraculous, horrible, scary thing. I don't know that anybody's really seen the miracle and horror of that. It took 100 years for it to retreat 8 miles from 1900 to 2000, from 2000 to 2010, it retreated 9 miles. So in 10 years, it retreated more than it had in the previous 100.
Okay. So why are we interested in Switzerland? Switzerland with Wyoming are headwaters mountainous areas. So as you can see from this slide, Wyoming is the headwaters of the Snake and Columbia River system, the Colorado River system, the Missouri River system up here, and the Mississippi over here. These two drainages end up coming together. And Switzerland has the same sort of topography and very similar. It is very similar in that it is the headwaters for the Rhine River, the Rhone River, the Danube River, and the Po River. These all flow into the Mediterranean. Of course, the Rhine flows into the Atlantic, and the Danube flows into the Black Sea. Switzerland at one time was almost entirely glaciated. All of the gray area here shows the glaciated area of Switzerland historically. The white area is the current glaciated area, and this Morteratsch Glacier that we've referenced is down in southeastern Switzerland here. Okay? Switzerland is a lot smaller. The entire country will fit inside our single county, but its population is much larger than Wyoming. And Wyoming lies at 42 degrees north latitude, Switzerland up at 47 degrees north latitude. But I've tilted this map and showing on the map of Wyoming the glaciated area in the Wind River Range of Wyoming. You can compare this by sliding these two areas together. So this is kind of why we're interested. Both headwaters states and or headwaters countries, and they're both headwaters. They're both glaciated areas where the glaciers are giant buffers, giant reservoirs in the uplands. Okay, alpine aquatic ecosystems are all rapidly changing. I've been studying with biologists for the last year and a half or so, and I could tell you more about this, but we've got to get on to the next. Now, how did we get the video going on that last one? Here's the, So this video is going to show us what's at risk. This works so well on my computer. This is a trailer from a French film by, I'll talk about that later.
very simple. Join us in this struggle as we seek to define what sustainable water use is going to be like in the Colorado River Basin in the future. And help us protect the headwaters. That's where most of the messages that Hunter gave this morning are absolutely critical. Quick for the students out there, if you want a guaranteed job with a lively future in the western United States, pick one of these majors, okay? And don't forget to wear your sunscreen. Otherwise, you're going to end up looking like me. Here are our sponsors. Thank you very much. We have maybe a few minutes for questions.
Maybe two questions.
You spoke about the amount of people serviced by the Colorado River Basin as 18 million, I think was the number you gave, and I heard people at the Utah Sierra Club say it's 28 million.
The 19 million figure was the people in the Southern California Water Conservancy District, which runs from north of Los Angeles all the way to the Mexican border.
Okay, because
but they don't get all of their water from Colorado. You know, there are massive projects all over California that funnel water down into that basin.
one of the figures, the 28 million, is used by SUA and the Utah Sierra Club to explain how many people would be impacted if fracking was allowed to happen in Greater Canyon lands. Do you have issues of fracking in Wyoming, trying to fight that being impacting the Colorado River Basin?
That's a little bit outside of my area, but I can give you some, what I read in the newspapers. We have big problems. Pavilion, Wyoming is a community that has lived basically surrounded by an oil and gas field, and they have been fracturing in that oil and gas field for decades. And the net result there is groundwater pollution that has migrated up, contrary to what the petroleum engineers promised, from tens of thousands of feet all the way to the surface aquifer where the pavilion draws its water. So fracking is a huge issue, especially for those communities that use groundwater. Most of what I've been talking about today has been surface runoff. Other questions? Yes.
Kind of a two-part question. What do you think it would take to get the Colorado River Basin states to renegotiate the Colorado River Compact? And what would a better agreement look like?
That's it. I couldn't have paid you. I couldn't have paid you to ask a better question than that. First, the pessimist would say it's going to take an act of God. I am saying, and hopefully I've convinced you of this, that this is a conversation that has to happen. It's inevitable. We have to not only renegotiate, but we've got to start living within our means. We've got to start projecting out into the future to make sure that generations that follow us are also going to be able to count on the available water. And so this is why I'm asking you to join us in this struggle, not just to renegotiate the Colorado River Compact, but to understand that there are limits to growth. There are limits in the amount of precipitation that we get in this basin, and that amount of precipitation is declining while the demand is going up, and it's getting more erratic every year. And climate change is only making the situation much worse.
I'm going to have to stop it there, I'm sorry. We have a...
Thank you for coming.
Thank you very much. I'll also remind you of our next session, which is coming up in about 8